Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we are going to start with a new concept in the chapter Coordinate Geometry. Today we are going to learn about the section formula, and later on we are going to solve few problems using the section formula. Now students, what exactly is this section formula and where it has been used in math? We have taken a line segment AB and there's a point C over here which actually divides the line segment AB into two parts. Can you see the two parts? Yes, of course. The two parts are segment AC and segment CB. So we have a line segment AB and we have taken a point C on the line segment such that this point C divides the line segment AB into two parts, which are segment AC and segment CB. Now, since this point lies on the line and it is a part of the line segment 2, that is why we say that this point C divides the line segment AB internally. Right now, there are two other variables that have been used over here. If you see, we have a small m written over here, we have a small n written over here. What does this indicate? So when you actually place a point on this line segment such that that point divides the line segment into two parts, which may be equal also, which may not be equal also, right? So the line gets divided into two parts and it gets divided into ratio m:n, right? So we can say that the point C divides this line segment AB into the ratio m:n. So let me explain you with a small example. Let's say we have a line segment PQ, okay? So we have a line segment PQ. Now if I take a point R on this line segment such that it divides this line into two parts, and if you try to build a relationship between these two parts, that is PR and RQ, so whatever is the length of PR, the double of its length would be the length of RQ. So let's say if PR is 2, then RQ would be 4. If PR is 6, then RQ would be 12. When you try to take the ratio of these two quantities and when you try to reduce the ratio, what ultimately you get is 1:2. Over here also 1:2. Now why 1:2? 2 ones are 2, 2 twos are 4. Similarly, 6 ones are 6 and 6 twos are 12. So here if you see, this line gets divided internally in the ratio 1:2, where if you consider this to be the one part of this line, of this entire line, then this corresponds to total two parts of this entire line. And here if you see in section formula, there are three quantities that are very, very important. I will tell you what exactly is the section formula and where it has been used. But before that, you all need to know that we have a line segment, we take a point on the line segment and that point is a part of the line segment such that that point C, whose coordinates are x and y, divides this line AB into two parts. Now when it gets divided into two parts, we have the ratio to be m and n. So the ratio is m:n of this particular line segment when it is divided by a point C. Now here if you are asked to find the coordinate of this dividing point, okay, then how are you going to find? So for that we are going to use the section formula. So section formula actually helps you to get the coordinates of the point that divides a particular line segment into two or more parts, okay, depending upon how many parts it gets divided into and the corresponding points you can actually calculate using the section formula. So the section formula is read as follows. If you want to get the coordinates for this point which divides the line segment into two parts, then the coordinates for this are, the formula for getting the coordinates x and y of C are mx2 plus mx1 upon m plus n, and this is my2 plus ny1 upon m plus n. Now students, I want you to closely observe. We are getting the coordinates for the point C. That is, we are supposed to find the x value and the y value for point C, which divides the line into two parts. Now this first quantity that we are getting, that is nothing but your x coordinate, that is value of x, and the second value that you are calculating, that is your y coordinate, that is your y value for the point C. Now here if you see, we have made use of x1, x2, y1, y2 and something called as m and n. Now what is x1, x2, y1, y2? So x1 and y1 are the coordinates of the end point A, and x2 and y2 are the coordinates of end point B. Whereas m and n are basically the quantities that are involved in the ratio. So m is to n is basically the ratio in which the line gets divided. Now in exam, if you have been given to find the coordinate of the point which divides the line segment, what quantities you need to know? So you need three quantities. The first thing is that you need the coordinates for the first point, then you need the coordinates for the second point, and finally you also need the ratio in which the line gets divided by the point, that is the value for m and n. So you need the value for x1, y1, x2, y2, and finally you need the ratio m is to n, right? So these are the three requirements. Let me write them over here. So what you need is the value for x1 and y1, value for x2 and y2, and finally the ratio in which the line gets divided. So if at all in exam the question comes, you first need to see whether all these three quantities are given. If yes, you can use the section formula to get the coordinates for the point that divides the line segment. Now let's solve the problem using section formula. The question says that find the coordinates of the point which divides the line segment joining the points 4, -3 and 8, 5 in the ratio 3:1 internally. So what is the question saying? That here we are having a line segment. Okay, so let us say this is the line segment and let's name it as AB. Are we given the endpoints or the coordinates of the endpoints? Yes, of course. So the first point that is given to us is 4, -3, and the second point that is given to us is 8, 5. Now they are saying that the line segment is getting divided internally in the ratio 3:1, meaning there is some point which is lying on this line such that the line gets divided in the ratio 3:1. Let us say that this point is C. Now our aim is to calculate the coordinates of C, that is the value for the x coordinate and the value for the y coordinate. So let us solve this problem. If we see, we do have the value for x1 and y1, we do have the value for x2 and y2, and yes, even the ratio is given to us. So we have the value for m as well as n. Now let's start the problem. So you will say using section formula. So using section formula, we get C of x, y would be equal to, you are supposed to mention the section formula. Now how you are going to remember it? Okay, so yes, what are we supposed to use? We are supposed to use this, we are supposed to use this, we are supposed to use this and this, wherein if you see, this is your x1, y1, x2, y2, your m value and your n value, right? Now first you are going to write m, and now since this is the first part of it corresponds to your x coordinates, so you are going to use the value of x1 and x2 only. Here there would be no involvement of y, that is y1 and y2. So with m you are going to take x2, so m into x2, m comes first, that is why now x2 will come second. Okay, plus n into x1 upon m plus n. Now similarly you are going to write the same term over here, but instead of x2 and x1, now you are going to use y2 and y1, because you are going to calculate the y coordinate for the point C. So since m comes first, therefore here y1 will not come, y2 is going to come. This is just a trick to remember the formula, right? So you have to just say it again and again so that you would remember. So in m and n, m comes first, hence now y2 is going to come second. So y2 plus n y1 upon m plus n. This is our formula. Now we just have to substitute the values. So the value for m in this case is 3. 3 multiplied by x2 is 8 plus n is 1 multiplied by x1 is 4 upon 3 plus 1, comma, again 3 multiplied by y2 is, I'm so sorry, it is, y2 is 5 plus 1 multiplied by y1 is minus 3, the whole upon 3 plus 1. Okay, now students, I would tell you that writing this formula inside these round brackets is very important, because you're actually finding the values for the x coordinate and y coordinate, and we saw that any coordinate is always written in the tuple form x comma y. So this representation is very important over here. Okay, now let's further solve this. So make sure that you use these round brackets only and not any other bracket. 3 into 8 is 24 plus 4 into 1 is 4 upon 4. Then we have 3 into 5 is 15 and 1 into minus 3 is minus 3 upon 4. So I get 28 upon 4, comma 15 minus 3 is 12 upon 4. So that is basically equal to, when I reduce these terms, 4 ones are 4, 4 sevens are 28, 4 ones are 4, 4 threes are 12. So I get the coordinates as 7, 3. So you can say that therefore the coordinates of point C are 7, 3. So in this problem, we just made, it was a pretty straightforward problem, and we just made the use of section formula over here, wherein we did know what were the endpoints, we didn't know in what ratio the line was divided, we just had to substitute the values into the distance formula and get the point. Okay, I hope you all have understood the first problem. Now students, let us move on to the next problem. The next question says that you need to find the coordinates of the trisection of the line segment joining the points 4, minus 1 and B as minus 2, 3. So we have a line segment AB, and you're supposed to find the coordinates of the trisection. Now what do you mean by trisection of the line segment? You just have to pick up this keyword and try to understand its meaning in normal English terms. Trisection of the line segment. When you say section, it means parts, right? And tri means 3. So here you are supposed to find the values of the coordinates P and Q such that these P and Q divides the line segment A and B into 3 parts, that is trisection, and these 3 parts are equal to each other, right? So there is a line segment AB which is been trisected by 2 points P and Q such that when it is been trisected by the points P and Q, it gets divided into 3 equal parts. So trisection in normal terms or in geometric terms, it means that a line getting divided into 3 equal parts. So here we have assumed that we have a line segment AB. Of course, the points are given to us and it's been trisected. So let the points P and Q be the points of trisection of this line AB. We would first write the coordinates that are given to us. So A is nothing but minus 4, 1 and 4, minus 1 and B as minus 2, 3. Now we would say that let P and Q be the points of trisection Now they are trisecting which line segment? Line segment AB. So let P and Q be the points of trisection of the line segment AB such that, now note this carefully, such that your AP would be equal to PQ would be equal to QB. This is very important, right? And we have derived this because it is given to us that the line is trisected, right? So since these are the points of trisection, therefore the line segment gets divided into three equal parts, and hence AP equals to PQ equals to QB. Now pay attention. How are we going to get the values of P and Q? The question is to find the values of P and Q. So how are we going to get these two values? How are we going to get the coordinate for P and Q over here? So for that, we are first at a time going to focus on one of these trisecting points. That is, first we would focus on P. Okay. So here if you see, let us now consider the line. Again, I'll draw it over here. A, then B, you have P and you have Q. These are the three equal parts. Now here if you see, just ignore this point, right? And just focus on this line segment. Okay, do consider this part and this part, 1, 2 and 3. Now these are the three equal parts, right? P is dividing this point AB. Now for now you just focus on this point and let us try to find out the ratio for this division. Okay, so if AB is a line segment and P is dividing this line segment into these two parts, then what would be the ratio for these two parts? If you see, if this part is, let's say, this much, means it's this much only, of course, but then if you try to guess that how much would be the length of PB, then of course it would be 2 times that of AP. Why am I saying that? Because these three parts are equal to each other. So if I take just one part of this, then remaining two parts would be, of course, together double of this part. So that is why in the beginning, when I was trying to explain you the definition, I did say that if one part is double of the other part, then the line gets divided into the ratio 1:2. Why is that so? Because here whatever would be the value, the second part is double of this value. So that is why we can say that this line segment gets divided internally in the ratio 1:2 with the help of the point P. So how mathematically you are going to present this? So you would say that therefore point P divides line segment AB internally in the ratio 1:2. Now students, we got the value of ratio, right? So we got the value of m:n. We do have the value for x1, y1 and x2, y2, right? So I know what is the ratio, I know what is the value for x1, y1, x2, y2. So can I get the coordinates for point P using the section formula? Yes. So again, by section formula, the coordinates for P, x comma y would be, now how are you supposed to remember the formula? M comes first, x2 comes second, n into x1, m plus n. Similarly, you are going to write the same formula for y coordinate. Now, the value for m over here is 1 and the value for n over here is 2. So just substitute 1 into x2 is -2 plus n is 2 into x1 is 4 upon 1 plus 2, comma 1 multiplied by y2 is 3 and y1 is -1. So 1 into 3 plus 2 into -1, the whole upon 1 plus 2. So that is equal to 1 into -2 is -2 plus 2 into 4 is 8. the whole upon 3 comma 1 into 3 is 3, so 3 2 into minus 1 is minus 2 the whole upon 3, right? So here we get the answer as 6 upon 3 multiply comma 3 minus 2 is 1, so that's 1 upon 3. If you try to reduce it, we get the answer as 3 ones are 3, 3 twos are 6. So the x coordinate is 2 and the y coordinate is 1 by 3. So these are the coordinates for point P. So we got the coordinates for point P, and the coordinates for point P are 2, 1 by 3. Again, I'll tell you how did we get it. We made use of the fact that P and Q divides the line segments into 3 equal parts. So if P and Q divides the line segments into 3 equal parts, it means that point P divides the line segment AB in the ratio 1:2, because AB would be one part and the remaining would be double of AB, and hence the ratio 1:2. Now in the similar pattern, we are going to solve for point Q and get its coordinates using the section formula only. So how are you going to do it? So again, I will draw the line AB with coordinates 4, -1 and -2, 3. And these are the 3 equal parts. Now this time, since I have already calculated the coordinates for P, I would be just focusing on Q. Now again students, here we are going to see that how actually Q divides the line segment in what ratio. So here if you see, if you consider this to be one part of this line and this to be the second part of this line, then now QB is half of this entire part AQ, or you can say AQ is double of QB. So now this line segment gets divided in the ratio 2:1. Earlier P was over here, and that is why the line segment got divided into 1:2, because it's clearly visible. Out of the 3 parts, 1 part is over here and 2 parts are on this side. But now since we have taken Q to be the second point, so here at first we have 2 parts and at the back we have the 1 part. So the line segment gets divided into the ratio 2:1. Now these are the values for M and N. Again, can we use section formula? So we are supposed to first write point Q divides the line segment in the ratio 2:1. Therefore, by section formula, again, your Q of x comma y, okay, the x and y coordinate of Q would be m into x2 plus n के साथ x1 upon m plus n. This is your x coordinate, hence all the xi's. And now m into y2 plus n into y1 upon m plus n. Just substitute the values for m and n over here, x1, x2 and y1, y2. So m in this case is 2 multiplied by your x1 remains the same, x2 remains the same, y1 and y2 remains the same. So this is x1, y1, this is your x2 and y2. So your x1 over here is 4 plus 1 multiplied by I'm so sorry, your x2, you're supposed to write x2 over here. So your x2 over here is -2 plus, now your n over here is 1 multiplied by x1 is 4, the whole upon 2 plus 1. Similarly, now you're supposed to write for y coordinate. So m over here is 2, y2 is 3 plus 1 multiplied by y1 over here is -1. The whole upon 2 plus 1. Now, on further solving, you have 2 into -2, it's -4, and 1 into 4 is 4 and 2 plus 1 is 3, comma, here if you see 2 into 3 is 6 and 1 into minus 1 is minus 1, so here minus would come, the whole upon m plus n would be 3 only. So minus 4 plus 4 is 0 and 0 upon 3 is 0 and 6 minus 1 is 5 upon 3, and these are the coordinates for Q. So you would say that therefore the coordinates for point Q are 0, 5 by 3. So to once again explain you this problem, we were been given that the line is trisected. It has been trisected and you were supposed to find the coordinates for the trisected line. So you were supposed to find the values for point P and Q, which we took over here to be the trisecting points. Now if you know that a line is trisected, it means that it has been divided into 3 equal parts. Using this property only and the section formula, you calculated the values for P and Q. So I hope you understood the second problem also. It is very easy. You just need to make use of the given fact that has been mentioned over here in the problem, that is the line has been trisected. Okay, so I hope you understood the second problem also. So with that we come to the end of today's class, and just to sum up today's class, we started with the section formula. We saw what exactly is section formula, and then we solved 2 problems using section formula. Now we are going to solve more problems using this section formula in the next class, and yes, we are also going to see the real life application of section formula also in the next class. So see you all in the next class. Thank you.